So this first data I'm going to show you is some information we gathered from Centropyge potteri, the potter's angelfish. We looked at about 40 individuals collected out of Kaneohe Bay, and we classified their gonads into 3 types. Okay. Like most fish, females have ovaries, males have testes, but there's also these guys that have ovotestes, which is literally just an ovary and a testis together. And these are particularly difficult to assign functionality to because sometimes they can be functional as male if there's sperm within the testis. Sometimes they can be functional as female if there's mature oocytes in there, and sometimes they function as neither. So we really had to evaluate what they were functioning as. This one right here, you've got very small unyoked oocytes, so it's not functional as female, but it did have sperm within there, so it was functional as male. For females, we evaluated maturity based on the presence of yoked oocytes. Some of the individuals we would come across had just these primary growth oocytes, and they were considered to be inactive, whether they're immature or just out of season. And then many of them would have these yoked oocytes indicating they had reached the size at reproductive maturity and may possibly be able to reproduce at the time of capture. Okay, so this just shows the size distribution and fish length of the 3 different gonad classes. As you would expect for a sex-changing fish, individuals with ovaries were a lot smaller than individuals with exclusive testes. And then up here in the middle, we have individuals with ovotestes, which are around the same size as individuals with testes. Just as Linetsky had found, we found that there is a significant difference in size. So we can go back and plot that information and look at the actual percent of individuals that are mature as any given sex to determine what our size at maturity is. Okay, so this first line you're showing right here, showing the percent maturity for a size class, and this first black line is females, and we see that the size at 50% maturity is right around 54 millimeters in total length. Okay. Females mature, get almost 100% maturity, and then as size increases, the proportion of mature females decreases, and the proportion of mature males increases. And we estimated that the size at 50% maturity for males was right around 84 millimeters in total length. And this was good because it actually was very similar to what we gleaned from Linetsky's data. So it indicated that size estimates from literature records can be very valuable. Okay. Here's the gonad information we gathered for the goatfish. And here we only found 2 different types of gonads, either ovaries or testes, so they were a lot easier to classify. And again, males we assigned as reproductively mature if we found sperm within the testes, and females we assigned as reproductively mature if we found vitellogenic oocytes in there. Something very strange happened, though. Of the 26 or 30 fish that we looked at, only 2 had vitellogenic oocytes. So the majority of females we looked at had only these small dark staining oocytes down here, which indicates that 1, they were either below the size at maturity, or 2, they were collected at a time when they weren't spawning. And it's hard to distinguish between the 2. Okay. The other thing is we found out that individuals with testes were significantly larger in size than individuals with ovaries. And usually in reef fishes, we assume the bigger the fish, the more eggs it's going to be producing. But if our data are correct, it indicates that the larger-bodied goatfish are predominantly going to be male. When we break this data down by functionality, that is, can they actually function as a female at the time, or can they actually function as a male, it starts to fall apart. Okay. So again, the majority of females that we surveyed were inactive. Down here, only 2 were active or had vitellogenic oocytes, but we did have a lot of reproductively active males and only 2 or 3 that were inactive. So what can we say about the size at maturity? Not a whole lot right now. Just for reference, this is the legal limit in which you can collect these goatfish. It's 7 inches or 177 millimeters. So it seems to protect more of these small-bodied, inactive females more than it does males. Okay, so where does that leave us? Well, we have a sex ratio of Potter's angelfish estimated from our own population of about 3 to 2. Now the sex ratio for this fish varies depending on location and habitat type, but our sex ratio estimate was in line with that of Phil Lobel, so we feel confident that we can use these literature records in the future. The size and maturity was also similar to what we found in the literature records. Females were a little bit larger at maturity than previously estimated, but males were right around the same size. Because the goatfish had few active females in our population, we can't say very much about the size and maturity for females. We definitely need to collect more gonads, hopefully from different areas. We're hoping to get access to some museum collections and do biopsies on gonads there. One thing for sure is that males, or at least individuals with testes, were significantly larger than females. So we're definitely going to have to do more work and obtain more gonadal data. So given that this is incomplete, what have we done? Well, we have made some accomplishments. In the past few months, we've completed our videogrammetry surveys. We now have about 13,500 meters of footage from both the fished area and the reserve area. And we've also collected or generated lots of life history information on the 3 species we're working on. Things like growth rates, mortality, fecundity, sex ratio, with a couple caveats, and also size and maturity. We were able to use some of this information to model biomass production and reproductive output, both inside and outside a reserve. And we were able to present this at 3 different meetings, the American Society of Ichthyologists and Herpetologists, the Hawaii Conservation Conference, and also the American Fisheries Society. Okay, so what do we have left to do? Well, we definitely have to look at more gonads for our goatfish, and in particular, we want to look at age versus sex. The fact that males of this goatfish are larger than females may indicate that females stop growing or slow growth once they become reproductively mature. It might also indicate that our sampling was a little bit skewed more towards males because of habitat associations. We also have to complete our final analysis incorporating this new data on size and maturity and also more videogrammetry that we haven't analyzed yet. We're planning to offer 2 workshops, one on life history analysis, so otoliths and gonads, and also laser videogrammetry in the next few weeks. And finally, we're hoping to eventually incorporate this in a manuscript and find somewhere to publish it. At the very end, I'd like to thank the following people and organizations for their help in the project. In particular, Brandon Ibarra was a student assistant working in our lab that did a lot of the gonad histology and also helped with hours and hours of video analysis. In particular, thanks to Coral Reef Initiative and thanks to the Department of Land and Natural Resources. Any questions?